Hey everybody, we are working on 3.1. We're going to look at this starter problem number 2. This is going to walk us kind of into this type of problem. So say we're given a polynomial and it has a factor of x minus 3. So we kind of learned about this in our last unit. It means that if we have a factor, then we know that its 0 is 3. And we could divide. So that's the first thing we're going to do is we're going to divide this polynomial by this factor. Okay, so we'll write down our 0. So again, our 0, what makes this be equal to 0? X would have to be 3. And that's what we put here in the front. And then we'll list down all the coefficients. So we have 1, -3, -25, and 75. Okay, and then we will synthetic divide. Okay, so we bring down the 1, that's our first step, and then we multiply, add, multiply, add, multiply, add. So we multiply this to give us 3, and then we end up getting a 0 when we add, and then we multiply again, that would give us 0, and then we add to give us -25, and then we multiply to give us -75, and we get a remainder of 0. Okay, so we could finish this up. We could, again, this ends up giving us a quadratic. So we get 1x squared plus 0x minus 25 is equal to 0. Okay, so we did that in our last unit. Okay, so the thing that's we're gonna add to that is we want to find all of the solutions. We found one of them, x equals 3. We have a quadratic left, which means we should have 2 more roots, 2 more solutions. So we know how to solve quadratics. Again, there's lots of different ways. We could factor, we could use quadratic formula, and there's a couple others that we learned about last year, but we're going to focus on those 2. So first off, is this factorable? Can we find something that multiplies to -25, multiplies to -25, and adds to 0? And if you think about it for a second, hopefully you'd see, oh yeah, we could do -5 and 5. So again, you're welcome to use the box, but for this one, the leading term is 1. So we could go straight and write down our factors. We'd get x minus 5 and x plus 5 is equal to 0. So then we would throw in the 0 product property. So if you're multiplying 2 things and it's equal to 0, then we know that either x minus 5 has got to be equal to 0 or x plus 5 has got to be equal to 0. And then we could solve by adding or subtracting 5, and we'd end up getting x equals 5 or x equals -5. So now we have all 3 solutions. Would have 3 from here, and then we'd have the 5 and the -5. Okay, so that's basically what we're going to be covering. The only thing that's going to be a little different is that you're not going to be given the factor. So we're going to spend a little time talking about what are some good choices that we could try to find some of our zeros. Okay, if you can find one of the zeros, then you end up getting a quadratic after you divide, and you know how to solve a quadratic. Okay, so there's some other examples you could give a try if you'd like. We'll get into the graphing part in the future. Okay, so first off, this is like number 1 on your homework. It wants you to list or write down, the number of roots. How many roots will be in each of these polynomials. So again, it's always based off of the highest exponent. So this one would have 4 solutions, and this one would have 15 solutions. Okay, some could be multiplicities, like same type, same number. multiple times, okay? So that's just a quick review. Okay, and this is the only other real thing that we need to make sure we get before we start doing these problems, okay? So this is called the rational root theorem. It basically tells us what are the possibilities, what are some of the numbers that could possibly work, could give us a root, okay? Obviously, if we plugged in just some random huge number, it's not going to give us one of our zeros, okay? There's only a certain number based off of these numbers that will actually give us the actual roots, okay? So let me give you an example of what we're going to want to do. Hopefully I can explain this a little better than I did in class, okay? So say you're given a polynomial. This one is in the blue, that's written in blue, is already in factored form. If we were to put it into standard form, I just want us to write down what the leading term is and what the constant would be. So again, to find the leading term, we would want to multiply all of the first terms, first terms. We'd get 2x to the third, okay? And then if we want to find the constant, again, the constant, we could just multiply all of the last terms, and we would end up getting a positive 6. Okay, so these are the things, these two numbers are the things that are needed to come up with these the factors. Okay, so it's all about the leading coefficient and the constant. Okay, so when we do this, the rational root theorem, it's just basically saying that the things that could possibly work are the factors of 6 and the factors of 2. So we'll call this on above, it talks about this is called P and this is called Q. So the possible factors are the factors of P over the factors of Q. So let's write down what the factors of P are. So the factors of P are 1, 2, 3, and 6. Those are the only numbers that can multiply to 6. And then the factors of Q, well, Q is 2, so we'd have 1 and 2. Okay, so we want to write down all of these possible combinations. So first off, we don't know if these numbers are going to be positive or negative, so we're going to write down a plus or minus. And then from there, we're going to start writing down all the combinations. So we could do 1 over 1, we could do 2 over 1, 3 over 1, and 6 over 1. But that is just 1, 2, 3, and 6. So those are the possible whole numbers that could give us zeros. These could be the possible integer roots, okay? And then we're also going to check out the denominator when it's 2. So we'd have 1/2. So maybe I'll write that first. So we'd have 1/2. Okay, we'd have 2 over 2, but 2 over 2 is just 1. We already have that. We could do 3 over 2. We don't have that. And then 6 over 2, we do have that. That's just 3. Okay? So that's not a great thing, but those are the possible rational roots. So we know that this is a third-degree polynomial. There's only going to be 3 that will actually work, but at least we can limit the possible things that can work. Okay, so if we kind of look at this, our solutions, like for these that we have, I wrote up in the blue above, the solutions that we would end up getting would be x equals 1/2, -3, and +2. And look what we've got. We have 1/2, we have 3, but it's going to be its negative, and we also have 2. Okay, so when you enter this into your homework, you're going to need to write these out separately. So we would do something like 1, 2, 3, 6, 1/2, 3/2, and then what I would do is I would just copy and paste, just using your Chromebook, or I imagine your phone could maybe do that too. And we'd want to paste it, and then we just want to change all the numbers to be negatives. Although I'm running out of room. You won't have this many on your homework, but this is these would be the possible rational roots. Okay? And again, all three of those that we've found are here. Okay? The thing is that we don't know this part. Okay? We don't know that. That's a mystery. And there are different ways that could still, multiply to 6 and have the leading coefficient being 2. Okay, so like for an example, we could have something that could be like this. Okay, if we were to find the leading term and the constant, you would get 2x to the third, and you'd get a plus 6 as the constant. So this has different zeros, but they have the same leading term and constant. Does that hopefully that makes some sense. But anyways, we're just going to go and try a couple really quick. So here we go. We've got our p. Our p is 8. Again, we don't care about the sign. We're doing plus and minus anyways. And our q would be 3. So we'll write down the factors of 8 would be 1, 2, 4, and 8. All the things that can go into it. And then we have 1 and 3. So if we want to write down all those combinations, this one's a little longer one. So we could do 1 over 1, which is just 1. 2 over 1 is 2. 4 over 1 is 4. 8 over 1 is 8. And then we'll do when the denominator is 3. So we would get 1 over 3, 2 over 3, 4 over 3, and 8 over 3. So here we have 8 options, but not really. We really have 16. Why? Because we have the plus or minus. So this has 16 possibilities. Or there's 16 possible. Okay. This one over here, I think we wrote all of those out. 1, 2, 3, 4, 5, 6. This would be like 6 possible. Okay. And you're just going to be writing these out. So let's try another one. 5. So the factors of 5 would be 1 and 5. And for here it was the leading coefficient, q, is 1. So we'd just write 1. So our options are 1 and 5, plus or minus. So again, on your homework, you'd want to write 1, 5, -1, and -5. And the order of these when you type them in doesn't matter. So if you wanted to do 1, -1, 5, -5, that would be fine too. Okay? All right, last example real quick. So we've got p is 4, q is 2. So factors of 4 would be 1, 2, and 4. And then for factors of 2 would be 1 and 2. And then we need to find all those combinations. So we'll have plus or minus 1 over 1, 2 over 1, 4 over 1, and then we'll do 1/2. And then next would be 2 over 2, which is just 1, which we have already. Check. And then 4 over 2 is just 2, which we already have. Check. So we just have 5 things here, but again, we'll have twice that much. So we'd have 1, -1, 2, -2, 4, -4, 1/2, and -1/2. Okay? And that's what we would put in. All right, so now let's combine what we just learned. Okay? So This is just I'm going to spend a second on this. So if we want to check if one of these, like, I don't know, for this one, if we want to see if one of these is a factor, we have like two choices. One, we could just take that 1 and plug it in like this and see if you get a 0, right? If it's a 0, then 1 is a root. If it's not 0, then it's not a root. Okay, so that's one way you could do it, is you could just plug in the numbers and see if you get what you're looking for. Okay, I'm gonna I don't know, that's an option, but I'm gonna do it using synthetic division. Okay, and I'll kind of maybe explain why. So here's like an example that you'll kind of see on the homework. You won't have like this stuff written here, but this is more just like a guide. So how many roots would this have? So we would have 3 because the degree is 3. So let's write down the possible rational roots. So again, these aren't the actual roots. These are just one of, or 3 of these are going to be your roots. Okay, so we've got P is 6 and Q is 1. If Q is 1, then we don't have fractions. So we're just going to write down the factors for 6. So here we would have plus or minus 1, 2, 3, and 6. So I know you're like, Mr. Warner, that's going to have 6 things. Do we have to do all 6 of these? And I'd say, no. Usually you'll find it in the first 1, 2, or 3 attempts, right? So this is what I'm going to get you started with, is we're going to start with try 1, okay? And we're going to try synthetic division. For me, I think it's faster for me. But again, you can always just plug that 1 into every x on your calculator and see what you get, okay? So we'll write our coefficients, 1, 2, -5, -6. Bring down the 1. And then again, you can either write lightly, so you could erase if you need to, or you could just draw another half box, okay? So here we'd multiply, add, multiply, add, -2, multiply, and we'd get -8. So we know that this isn't a factor, okay? So I would either just erase with your eraser, and then I would try again. So now we'll maybe try -1. I would just start with the easier numbers, like 1 and -1. Oftentimes that will do it. If not, we'll try 2. So here, let's try again. So -1 times 1 is -1. So we'd add to 1. We'd multiply, add, multiply, add. So here, this is one of our roots. So we could say x is equal to -1. That's one of our roots. Okay, so now we have what's left would be our quadratic. We'd have x squared plus 1x minus 6 is equal to 0. And then we'll just need to find, well, what multiplies to -6 and also adds to 1. Since a is 1, like the leading coefficient, we can just use the shortcut. We can just write down our factors. All right, so what could work? We could maybe do 3 minus 2. Oh, I think I totally wrote that. Okay, 3 minus 2 would give you 1. And if you multiplied those, then that works out great. Okay, so we would end up getting x plus 3, x minus 2, and then we just need to find the zeros. So again, we set each of these equal to 0, each factor, and we would end up getting x equals -3 and a positive 2. And then I'm going to add that -1 that we found here. Okay? And that's the process. Okay, let's try another one. So this is like the 6, 7, and 8 on your homework. Okay. This one, I'm trying to decide if I want to go over this one. Sure, let's do it, okay? This one actually tells you, well, we're going to say that it tells you that it's a factor. So it's a lot like the one we did at the very beginning. So we would say that the 0 is 1, and we'd get 1, -7, 15, and -9. Would bring it down, would multiply, add, multiply, add, multiply, and we'd get a 0. Okay, so we end up getting x squared minus 6x plus 9. And then would say, well, what multiplies to 9 and adds to -6? So that would give us x minus 3 and x minus 3. And our roots would be 3, 3, and 1. Okay? All right, so let's go to this example. Again, we want to write down the possible rational roots. So again, a is 1, so there won't be a fraction. It's just going to be the factors of 8. So we would have plus or minus 1, 2, 4, and 8. Again, I know this is like 8 possibilities, but usually in just a couple tries, you'll end up getting it, okay? So let's try 1 and write down the coefficients. Okay, bring it down, would multiply, add, multiply, add, multiply, add. So that doesn't work. So I'm going to just erase. And I'm going to try -1. So multiply, add, multiply, add, multiply, add. And that still doesn't work. So let's try one more. Again, it goes kind of, hopefully you think it kind of goes quick. So let's try a +2. Maybe I'll erase that. So +2. And we would multiply, add, multiply, add, multiply. Oh yeah, so we got one that works. So x equals 2 is one of our roots, and now we just need to factor this quadratic. What multiplies to 4 and adds to 4? Well, that would be 2 and 2. So x plus 2 equals to 0. So x would have to be -2 and -2. And then we'll bring this one back down, and we'd get a +2. So those would be our 3 roots. Okay. I'm hoping this is kind of making sense. All right, so let's keep going. I think we just have a couple left. I think I'll probably skip this one. I think it's very similar to 8 that we did. So let's go and do these last two. I added another problem because you'll have a couple like that on the homework. Okay. So what's different here is the leading coefficient is 2. So if you ever have a leading coefficient, you'll probably have at least one of your roots will be a fraction. So when we do this, what did we do? The P and Q, so P here is 4, Q is 2. So the possible rational roots would be 1, 2, and 4. And for the denominator, we'd have 1 and 2. And so let's write these out. So we'd get 1, 2, and 4. That's just by doing 1 divide 1, 2 divide 1, 4 divide 1. Okay? And then we're going to try 1 over 2. I think as our last one would be 1/2. And then everything else is just a duplicate when you simplify the fraction. So those are our options that can work. And then we're going to do synthetic divide. Start with 1. So we got our coefficients are 2, 7, -5, and -4. Bring down the 2, and then we'll multiply, add, multiply, add, multiply. Oh yeah, we got another one. Okay, so our first root that we found is x equals 1. And now we have a quadratic. So that looks like there we go. And now, again, this is different because a isn't 1, it's 2. So we'll still do what multiplies to 8 and adds to 9. That would have to be 1 and 8. But then we can't just go straight to our factors. So we'll have to use the box. Just have a couple of those on the homework. Again, your first term is your first box. Your last term is your last box. And then your puzzle, got to add those x's in there, are the other 2 boxes. So we could factor out a x, a 4, a 2x, and a 1. Again, you can check the multiplication, make sure it multiplies correctly. That looks great. And then I'm going to write down our factors. And then we just need to solve. So either 2x plus 1 has to be equal to 0, or x plus 4 has got to be equal to 0. So for this one, this is probably the easier one. X would have to be -4. Here, I would encourage you to just actually solve this part. So we'd subtract 1 to both sides. So 2x equals -1. And then we'd have to divide both sides by 2. So that's our other. So we've got -1/2. Well, I'll just rewrite it. So x is equal to -1/2, -4, and 1. Again, the 1 comes from here. Okay? All right, so our last example, again, what kind of looks a little different is there's no constant. So how are we supposed to do the rational root theorem if we don't have a constant? Okay? So if there's no constant, that means we have a greatest common factor of x, at least an x, right? And we could factor that out. So we would get an x out in the front, we'd divide everything by an x, and we would get x squared plus 5x plus 6. And then we just need to do factoring. So what could multiply to 6 and add to the middle term, which is 5? I think that would be 2 and 3. So we'd end up getting something like this. Okay, so how do we come up with our 3 roots? Again, either x has to be 0, x plus 2 has got to be equal to 0, or x plus 3 has got to be 0. So our roots would be 0, -2, and -3. Okay, hopefully that was helpful. If you have any questions, please come and talk to me, and I could try and explain it maybe a different way if you need to. All right, we'll see you guys later.